my recordings are at one place only. Okay. Mm, yeah. Okay. So this was the numerical, right? This was the numerical. So this is a numerical. Let us solve this numerical. Okay, a silicon transistor connected in common emitter configuration, right? Common emitter configuration. I will just change the color. Common emitter configuration with voltage divider bias, right? Means R1 and R2 is there. Is shown in the figure. VCC is 22.5 volts. That is, this is 22.5 volts. Okay. RC is 5.6 kilo ohms. This is 5.6 kilo ohms, right? And then R1 is 90 kilo ohms. This is 90 kilo ohms, and R2 is 10 kilo ohms. Okay. And then yes, RE is 1 kilo ohm. This is 1 kilo ohm, right? And beta for this transistor is 55. Okay. So we need to find the Q point, right? So what is Q point? Q point find out करना है मतलब क्या करना है आपको? What we need to find?
Values of
I see.
VCE, IC.
Q point means values of VCE and
I
IC.
see.
So these values we need to find. Okay. So can you solve this problem? Yes, no.
Yes, sir.
Okay.
Yes, sir.
So let me give the solution. Okay. And then rest of the problems you may try on. Okay. So this is the problem. So how to solve it? How to solve it? So can we draw its equivalent circuit? Can we draw its equivalent circuit? We can have a circuit like this, right? We can have a circuit like this. RC, RB, VB. This is RE. Correct? Yes, no?
Yes, sir.
Yes,
Okay.
sir.
And this is 0.7 volts, VBE. Correct? What is
Yes,
RB?
sir.
What is RB? R1 parallel with R2. That is 90 into 10 divided by
R1 plus R2.
plus 10. Right? Correct? So
Yes,
it
sir.
will be, तो भी गड़बड़ हो गया क्या? 100, right?
Sir.
So it will be
10 है
100,
ना ये.
100, 100. बराबर है ना?
Yes, sir.
Correct?
Sir
9
9 है बराबर.
Yes, sir.
okay. Huh?
Yes, sir, it is okay.
9 kilo ohms,
Yes,
right?
sir. It is
And
correct.
VB will be R2 upon R1 plus R2 multiplied by
VCC.
2.5. That is VCC, right? So can you calculate this? 10 by 100. So it will be 2.25 volts. Correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes. 2.25. And then this RB is 9K. So therefore, we can apply a loop here, right? So this VB is equal to IBRB plus zero point 0.7, correct? So IB will be VB. VB is what? 2.25
5,
minus zero point 0.7 divided by RB is 9.
9.
So how much is RB? IB? Can you calculate it? So like this you will get IB. Once you get IB, can you find IC? IC is beta times IB, right? So beta is how much? 55 times IB, correct? Yes, no?
Yes, sir. Yes, sir.
Yes,
Yes, sir.
sir.
And then this voltage here is VCE, right? and this is, let us suppose this is VCC 22.5. Yes.
Yes, sir.
So
Yes,
with
sir.
green color, I will
Yes,
try
sir.
to find this thing. Okay. So this applied voltage, this total voltage, right? This 22.5 voltage is nothing but ICRC, right? Minus VCE minus IERE. Correct?
Yes, sir.
Yes, sir.
Okay. So
Yes,
what
sir.
is IE? Okay. So what is IE? IB plus IC.
I see.
Okay. So therefore, can we calculate VCE? VCE will be 22.5 minus IC
ICRC
पता
I
है,
see.
RC पता है,
Ari.
minus IERE
right? Minus or plus? This is plus, right?
minus
Yes, sir.
minus IERE.
Minus IE,
Ari.
correct?
Yes, sir.
ओके सो इज इट ओके, समझ में आ रहा है आपको क्या चल रहा है?
Yes, sir.
बराबर है।
हाँ
सबसे
सर
पहले
हाँ
देखिए, सबसे पहले ये वैल्यू मिलेगी आपको, आई बी मिल जाएगा, आई बी मिल जाएगा तो बीटा भी पता है, तो आई बी का वैल्यू यहाँ पर रखिए, आई सी मिल जाएगा, आई सी मिला, आई बी मिला, राइट? तो फिर आपको आई ई मिल जाएगा, आई ई मिलने के बाद में आई मिलेगा, आर ई पता है, आर सी पता है, आई सी पता है, यू गेट टी सी। यस नो?
yes sir
Yes, sir.
Yes, sir.
So let us check, right? Let us check the possibility, right? Yes. So VB, correct? 2.25, बराबर है? ये नहीं
Yes,
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 sir.
sir.
उसके
Yes,
बाद
sir.
में फिर
yes
Yes, sir.
आप
yes
VB VB we know, okay? And then ICQ उन्होंने निकाला और IE, right? IE is 1.55 divided by 1000. V voltage at emitter, voltage at emitter, it, it is found out, right? Like they have used another logic, right? ये जो voltage है, this is your VC, this is your VB, and this is your VE, VE, right? So we know VBE is equal to VB minus VE,
yes
right? So this is zero
yes sir
point 0.7, VB is 2.25 minus VE.
we
So therefore VE is what? 2.25 minus 0.7. VE will be आपको,
1.55
correct? Yes, no?
Yes,
yes
sir.
sir
If
Yes,
you
sir.
know this VE, if you know this VE, can you find IE? Yes.
yes sir
Yes, sir.
Yes. How to find
Yes,
IE?
sir.
I by R
E by?
V by R
So this is VE divided by
R R is sir
RE is equal to I. Getting?
yes sir
So once you get IE, VCC, VC is equal to what? VC is equal to, okay, here I can write an equation, VCC, right, is equal to IC,
ICRC plus
RC
VCE.
plus VC, only VC, okay. So from here VC is equal to VCC minus IC RC. So this
RC.
equation they have used, correct? You will get the value of VC from this equation, correct?
Yes,
Yes,
sir.
sir.
And then you can calculate this VC minus VE is equal to VCE, correct? Yes, no?
yes sir yes sir
So you
Yes,
know
sir.
VCE,
Yes, sir.
you know IC, right? So you can get this Q point. This is another way of getting the Q point. Yes, any problem in this?
No, sir.
No,
no
sir.
sir
Okay, okay. So one of the solution which I have provided. So just confirm the answers with this. The answers may get tally. Okay. So similarly, this is one problem. I will keep you this problem as a homework. Okay. Solution is also given. Okay. So now let us start with some topic called as last topic of this chapter, right? Called as hybrid parameter. Okay. Now this hybrid parameter, right? They are also known as H parameter. क्या बोलेंगे इसको आप? H parameters, right? Now, what is this hybrid parameters? These hybrid parameters are nothing but it will represent the relationship between the voltage and current in the two-port network. Now, what is two-port network? What is two-port network? So a network which have one input and one output, that is your two-port network. Okay. So we can represent the network with various ratios. बराबर है कौन से रेशियो हो सकते हैं that can be z parameters, that can be y parameters, or that can be voltage ratio or current ratio or anything. Okay. So any problem in this? Yes.
No, sir.
No,
Okay,
sir.
okay. Now, our transistor, right? Our transistor is having an input, right? Let us suppose common emitter amplifier. We are giving input. Where we are giving the input at the base, right? So there will be some input voltage. There will be some input current. Correct? Yes, no.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yes, sir.
And output also we are taking at the collector. So there will be some output current, that is IC, and there will be some output voltage, that is VC. Correct?
Yes, sir.
So, Suniye, the thing is that if I want to draw a block diagram of a transistor, or just I want to represent this is your transistor, can I say this is the input of the transistor and this is the output of the transistor? Yes, no?
Yes, sir.
Yes, sir.
Input is always given between input terminal and ground. इसके बीच में आप input देते हो, correct?
Yes, sir.
Yes, sir.
Right? So let us suppose there is some V in voltage you are giving as an input. Due to that input, some current I in is flowing inside the transistor, correct?
Yes, yes, sir.
And then output you are getting, that is, let us suppose this is your output IO, and then there will be some output voltage, we will call it as VO. Okay? Yes? So if it is a
Yes.
common emitter amplifier, this I in will be your I, common emitter में IB. This I naught is your IC.
I see.
Okay. Now, is it correct? Yes, no?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
So here we are getting four parameters, that is input voltage, input current, output current, and output voltage, right? Yes. Okay.
Yes, sir.
Now this is your transistor. This is your transistor. A transistor, we can replace it. This is your symbol of the transistor, right? But any device we can represent it with its equivalent electrical circuit, right? So equivalent electrical circuit means what? We want to represent it in terms of resistance or impedance or voltage source or current source, correct? Okay. So the equivalent of the transistor, we can represent it like this. So this is the equivalent, hybrid equivalence model of a transistor, right? So what is this? So there will be some HI, right? There is some resistor, okay? Let us name it as input resistor, HI, okay? Then always input resistance is in series, always input resistance is in series. There will be some output resistance called as HO. R naught is always in parallel, right? Okay. Now, here
That.
there is a current source. Hello. Here there is a voltage source. I will just change the color.
Yes, sir.
Yeah. So this is your voltage source, right? HR into V naught, and this is your current source. Okay. Now we have V naught input voltage, we have I naught I in input current, I naught output current, and V naught output voltage, right? And then there are some constants, right? So there are some constants or there are some ratios which we call it as hybrid parameters. So one of it is we are call it as HI, another is HR, third one is HF, and fourth one is H naught. Okay. Now, what are these hybrid parameters? So we will see that. But are you understanding what is this? This is nothing but this is the equivalent model. Means if we want to represent the transistor in terms of either current source or voltage source or maybe a resistance or maybe admittance, we can represent the transistor by this equivalent model. Yes? Yes, no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, see, here I can write an equation. Here, can we write some equation? Here or in any of the input circuit, right? We can always write an equation like V, right? Okay. For example, this here. What equation I can write? This VI is nothing but sum of
I
into
and HI.
HI. Sorry, instead of R, I'll write here HI plus this one.
H
This is what HR into
H V naught.
not. Okay. Similarly, this voltage, instead of this current is flowing here, and here is some current, and here is some current, right? Getting? So this
Yes,
I
sir.
naught is nothing but some current HF into II, right? Plus some current is flowing in this, right? So what is this current? This current will be V by R. What is voltage across it? V naught, right?
Yes,
What
sir.
is voltage
Sir,
across it? V naught. So this will be V naught
by
divided
H
by
naught.
some resistance, right?
H
So I will
naught.
call it as constant, that is H naught. Okay? Yes?
Yes,
Yes,
sir.
sir.
Okay. Now I will try to write this VI is equal to II into H11 plus, yes, H12 into V naught, and this I can write it as I naught is equal to, देखिए, I1 into H21 plus H22 into V naught, correct? Yes, no?
Yes, sir.
H11 is
Yes.
nothing but your
Yes, sir.
okay. So I get these two equations. Suniye, I get these two equations, simple equations, right? One is V naught. V naught is what? H11 into H11 into I1 बोलता हूँ मैं I1 और I input, right? Plus H12 into, बोलिए क्या बोल रहा था? H12 into
V.
V1 और V in, right?
Yes.
I in V in बोल देता हूँ, चलेगा? Okay.
Yes, sir.
And then this I naught output current is nothing but H21 into, okay, यहाँ पर मैं क्या करता हूँ, यहाँ पर लिखता हूँ, and then this second equation was I naught is equal to H21 into I in
1.
plus H22 into
Yes, sir.
V in, चलेगा?
It should,
Yes, sir.
Yes.
sir, excuse me,
Okay.
sir.
Now if I want to find
It
out the
should be
value,
V in I
yes,
input by H22, na. It should be V
हाँ
input by H22, na.
हाँ मैं बताता हूँ आपको, कुछ तो भी कांस्टेंट है, राइट? I will just come on that. Okay, that is your admittance part. What is admittance? You know, opposite of resistance. So we will come there. Okay, we will come there. Now,
Yes, sir. Yes,
if
sir.
I want to calculate H11, what is H11? पहले हम क्या करेंगे? इनपुट को जीरो रखेंगे, राइट? क्या करेंगे? इनपुट को, ये इनपुट अगर जीरो है तो ये पूरा पार्ट जीरो हो जाएगा, राइट? So this will be V naught divided by I in, correct? Yes, no?
Yes, sir.
Yes,
Yes,
ये
sir.
जब कैलकुलेट
Yes.
कर रहे थे ना, ये जब कैलकुलेट कर रहे थे तब मैंने क्या किया? ये लाइन मार के, मतलब दिस इज योर line, and then I am writing when I was calculating H11 at that time I was keeping B in is equal to 0. Correct? बराबर है?
Yes, sir.
Okay, sir.
Simple है?
Yes, sir.
Similarly,
Yes, sir.
Yes, sir.
okay. So, okay. This is your input. This is also input, right? So when I was calculating H11, I used to calculate V0 divided by I in when V in was equal to 0, correct?
0.
ओके सिमिलरली यहाँ पर भी अगर V in को 0 रखा, यहाँ पर भी अगर V in को 0 रखा, राइट, तो फिर क्या निकलेगा? H21 इज नथिंग बट I नॉट डिवाइडेड बाय
I
I in,
input.
लेकिन यहाँ पर क्या था? V in क्या था? 0,
0.
0.
करेक्ट? ओके,
Yes, sir.
यस,
Yes, sir.
नाउ
Sir.
नाउ सिमिलरली V in को 0 रखा है, V in को क्या किया? 0 रखा, V in को 0 रखा मतलब क्या? शॉर्ट सर्किट कर दिया, राइट? V in को 0 रखा मतलब क्या? शॉर्ट सर्किट किया ना, बराबर है?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
Yes,
इनपुट
sir.
को शॉर्ट सर्किट कर दिया मैंने, देखिए V in को 0 रखा मतलब यहाँ पर 0 वोल्ट मतलब क्या? वोल्टेज अक्रॉस शॉर्ट सर्किट इज 0, यहाँ पर मैंने शॉर्ट सर्किट कर दिया, करेक्ट?
Yes, sir.
ओके,
Yes, sir.
so this is short circuit, यहाँ पर भी short circuit कर दिया, okay? Yes, now with let us suppose yellow color I am writing here, if I want to calculate H12 कैसे कैलकुलेट करेंगे? H12 जब कैलकुलेट करना है तो हमें I in को क्या रखना पड़ेगा?
0.
0.
बराबर है?
Yes,
तो
sir.
H12 का वैल्यू क्या आएगा? V
V0
डिवाइडेड बाय
V input.
ओके। सिमिलरली H22 का वैल्यू रखेंगे तो इसको अगर हमने 0 रखा मतलब क्या?
I naught
not
upon V
I
in.
not by input.
समझ में आया?
Yes, sir.
तो इसको जब
Yes,
हम
sir.
ये
Yes, sir.
कैलकुलेट किया तो हमने क्या किया? ओपन सर्किट किया, इसको भी हमने क्या किया? ओपन सर्किट किया, यस नो?
Yes,
Yes,
sir.
sir.
ओके ओके, अभी देखिए V बाय I क्या है? ये क्या है? रेजिस्टेंस है ना,
Yes, sir.
Yes, sir.
शॉर्ट
हाँ,
सर्किट रेजिस्टेंस है, करेक्ट? यस
Yes,
नो?
sir.
Yes, sir.
ओके, ये क्या है? ओपन सर्किट है, लेकिन ये क्या है? देखिए रेजिस्टेंस अगर ये है तो इसका उल्टा जो होता है उसको क्या बोलेंगे हम? एडमिटेंस। क्या बोलेंगे? एडमिटेंस। नहीं तो y इज इक्वल टू 1 बाय आर, ये पता है ना आपको?
Yes, sir.
रेजिस्टेंस का उल्टा
Yes,
होता है
sir.
एडमिटेंस,
Yes, sir.
राइट?
Yes, sir.
So can I say this is your open circuit admittance,
Yes, sir.
Yes, sir.
right? Okay,
Yes.
Yes, sir.
yes no? ये वोल्टेज बाय
Yes,
वोल्टेज, आउटपुट वोल्टेज बाय इनपुट वोल्टेज क्या होता है?
Gain.
ये भी आउटपुट करंट बाय इनपुट करंट, ये क्या है?
Gain.
Gain.
वेरी गुड। ये कौन सा गेन है? वोल्टेज बाय वोल्टेज
Voltage gain.
गेन।
Voltage gain.
Current gain.
Current gain.
समझ में आ रहा है?
Yes,
Yes.
sir.
यस
Yes,
नो?
sir.
ओके,
Yes, sir.
नाउ आई विल जस्ट शिफ्ट ऑन द स्लाइड। अभी आपको समझ में आएगा ये सब मैं क्या क्यों बोल रहा था, ये सब मैथमेटिक्स क्यों, राइट? नाउ यस, तो सेम इक्वेशंस है हमारे।
Yes, sir.
Yes, sir.
Okay. So can I say this is your short circuit इनपुट साइड में कैलकुलेट हो रहा है, इसीलिए इनपुट रेजिस्टेंस। सो रेजिस्टेंस को हम इम्पीडेंस भी बोलते हैं, राइट?
Yes,
So
sir.
can I say
Yes, sir.
Yes.
that
Yes,
is
sir.
V1 by V in by I in when V0 is equal to 0, V0 is equal to 0, इसका मतलब ये होता है कि ये होता है शॉर्ट सर्किट, राइट? So whenever V in is equal to 0 इसका मतलब ये होता है शॉर्ट सर्किट इनपुट इम्पीडेंस पैरामीटर, करेक्ट?
Yes, sir.
Yes, sir.
सिमिलरली H12 इज व्हाट? ये ओपन सर्किट, राइट? जब करंट 0 होता है तो ओपन सर्किट में करंट फ्लो होता है क्या? नहीं, ओपन सर्किट, राइट? वोल्टेज रेशियो और वोल्टेज गेन, करेक्ट? यस नो?
Yes, sir.
Yes, sir.
ओके
Yes, sir.
ओके, and then next one is your uh, forward current gain or forward current ratio, short circuit, and this is I naught is open circuit. I naught by V naught is what? Admittance. कहाँ पर है? Output में. So that's why it is called as output admittance. Correct?
Yes, sir.
Yes, sir.
Yes, no? Okay.
Yes.
एक गलती हो गई इसमें.
Yes, sir.
एक गलती हो गई इसमें. इसमें ना H12 जो है H12 this will be V in, right? On equation this was V in and this was V out, right? तो यहाँ पर हमारा V in चाहिए, यहाँ पर V naught चाहिए. So this will be रिवर्स वोल्टेज गेन है ना, इनपुट बाय आउटपुट. ओके, सो रिवर्स को ट्रांसवर्स भी बोलते हैं. सो दैट्स व्हाई दिस वी कैन से इट एज ट्रांसफर वोल्टेज पैरामीटर, राइट? ट्रांसफर मतलब क्या? रिवर्स वोल्टेज. जैसे वोल्टेज गेन क्या होता है? वी नॉट बाय वी इन.
V.
तो वोल्टेज गेन का उल्टा बोलते हैं हम ट्रांसफर वोल्टेज रेशियो पैरामीटर. ओके, रिवर्स वोल्टेज गेन. ओके, और रिवर्स ट्रांसफर वोल्टेज रेशियो ऐसे बोलेंगे इसको. Okay, any problem in this?
No, sir.
No, sir.
No, sir.
So what is this? This is nothing but इतना ही ध्यान में रखिए, ज़्यादा डीप में मत जाओ. This is the hybrid equivalent of the transistor, and we are representing the hybrid equivalent by using the hybrid parameters. And what are the hybrid parameters? H11, H12, H21, H22. इसको नाम ऐसे क्यों दिए पता है क्या? क्योंकि आप ऐसे लिख सकते हो ना, मैट्रिक्स फॉर्म में इसको ऐसे लिख सकते हो. क्या लिख सकते हो? V in and I naught, right? And then we can write a matrix H11, H12, H21, and H22. And here we can write it as I in and V naught, right? So if I just go on the previous slide, right? By using this, can you form this equation? Right, by using the matrix multiplication, H11 into I in plus H12 into V naught will give you this equation. Correct? Yes, no?
Yes, sir.
Yes, sir.
Okay.
Sir.
So just these basic things are there for the hybrid parameter. So what is hybrid parameter? Now I will just come back to the original slide. That hybrid parameter is nothing but it is also known as H parameter, and we represent this hybrid parameter to show the relation between the input and output current between the two port network, right? So H parameter are useful in describing the input output characteristics of the circuit. Okay, so H parameter we can always show by these two equations, right? These two are the main equations, and mostly what is this? H11, H21, H12, and H22. These are nothing but the hybrid parameters and its names, right? And we can represent the transistor, right? So this AC equivalent circuit we can represent by using this hybrid equivalent model. Okay.
Yes, sir.
Yes, sir.
So this is the basic hybrid parameter. So इसका मतलब ये होता है कि if you want to represent the transistor by some circuit, so you can simply represent by using this circuit. Okay. And the detailed AC analysis is there in the second year of your syllabus, right? EC. So don't go in that deep. Okay. So till transistor as an amplifier, you have to be thorough. Okay. And some of the things of hybrid parameter. So now we can just have simple questions, right? For example, right, this is the hybrid parameter, okay? And what is the unit? H12, H21, 221, right? So units कैसे होंगे इसके?
B.
वोल्टेज गेन तो
ओम।
इसका तो यूनिटलेस होगा ना सर.
H11 is what? H11 is resistance. So इसका unit क्या होगा?
ओम।
H12 is what?
Ohm.
यूनिट नहीं होगा क्योंकि ये रेशियो है. H21 क्या है?
करंट गेन.
Current gain.
फिर से यूनिट है क्या? नहीं है.
U.
H22 क्या है? Reverse resistance.
Reverse
Admittance.
resistance.
So admittance 1 by ohm is called as mho.
ओ.
समझ में आ रहा है?
Yes,
चारों
sir.
की यूनिट
Yes, sir.
बता दी है मैंने. H11 ohm, H22 mho, H21 and H12 don't have any unit. Getting?
Yes, sir.
Yes, sir.
The current gain of an amplifier as the load resistance dash. Current gain और बोलिए करंट गेन का और लोड रेजिस्टेंस का क्या फर्क होता है? So the current gain decreases as the load resistance increases.
Increases.
Load resistance should always be less. Input resistance should always be as high as possible. Load resistance should always be as low as possible. Getting? Any problem in
Yes,
this?
sir. No,
No,
sir.
sir.
This was the transistor, right? In detail, and जो आपको पढ़ा है वो सही से पढ़िए, right? And if you have any difficulties, we